Hey, good morning, everybody. How you doing today? Happy Monday. Hope you had a good weekend. All right. It's a little snowy, although it's supposed to snow more, right? It's hopefully one of the perks of not having to drive in here. All right, we got a couple things on tap today. We're going to talk about the Lab 2. Had a couple questions. Yeah, and I see SB Java, you had some questions about Lab 2 for sure. We can take a look at that and see what's going on. And we're going to wrap up oh my goodness, the second chapter. I need more coffee. It's the pot is brewing right now. We have to run out there and get some in a little bit. So we're gonna wrap up the. I like to call this one the first chapter. I don't know. It's chapter 2, but essentially, nope, that's the wrong link. It's like the first chapter we actually get in and start doing stuff. So we'll wrap that one up. There's a couple interesting topics we'll get to. We'll dive deeper on them later, but it makes everything a little more interesting if we start talking about some of these things, which is fun. All right, so we're wrapping up chapter 2, and then we'll look at our first project as well, because we needed, sorry, I had to bump those down, because we needed to get the rest of this material before we can talk about that first project, okay? That sound like a good plan? Yeah, so SP Java, do you want to chat after so you can show me the error you're getting? Let me fire up Netbeans. And we'll take a look, see how far we got, and go from there. Yeah, sounds good. Yeah, I think if we bump that just a little bit, it should be fine. Let's see. Oh, trying to find, it's not cooperating, of course. Oh, goodness. Let's see. I'm going to pull up that syllabus here. Open that folder. And the file explorer here in Windows 11 is way slower than it used to be. It's really sad. It used to be like a pretty quick tool. Now it's just crawling. No. There we go. All right, and now that we've made it to week 3 as well, I believe our group tutor, Mr. Tim, will start offering those group sessions. There's not quite as much to do the first little while. So now we've gotten into some content, we got some projects to work on, some labs and things. I think those will be starting up. All right, so we move this one here. So if we do project 1 this week, and then project 2 that week, I think that works okay. It'll be due like when the midterm starts, but that should be fine. I think that'll work out okay. So this, yeah, I think that'll work nice. Let me save that. And we can update D2L here, just to make that look a little prettier. And I had to close that. I had so much trouble uploading stuff when the file was open, and I was really confused about why it didn't want to work. All right, so it should be updated there. Awesome. Let's take a look at Netbeans. Close these projects here. And we'll go open ours. All right, so we got to find 1500 for Monday, Wednesday. There we go. And this was the chapter 2 project. So we had looked at ways of working with integer values, right, whole numbers. We've looked at ways of using doubles, which are our numbers with decimal places. Generally, I don't like floats. Numbers with decimal places that are a little smaller here. Longs are the really big integer values. And then just as a fun thing here, you can add underscores anywhere you want. So they're great to add in between the place groupings instead of commas. You can't have commas because I don't know why you can't have commas, but you can put underscores in. So we can add underscores for things. A character is a single character. A string is a bunch of characters. So we can have variables that store strings, and we use full quotes for those. And then if we take strings plus strings, it's not really addition, right? It's concatenation. We're taking two strings and just jamming them together here, and they're going to touch. And then Java is relatively smart most of the time. If we take a string plus a number, it will concatenate it for us as well, because you can't do the arithmetic. There's no arithmetic to have happen here. We looked at arithmetic. Everything on the right happens first, and then it assigns to the left. So kind of that flow, everything on the right is evaluated. We figure out what the value should be, and then we store it in the value on the left. Right? So this is the assignment operator. It's not an equals operator. And then we looked at some combined assignment operators. It's just a shortcut here. This is real common because we don't want to have to type out this long thing if we can help it. And then we looked at scanner here. This is part of the Java library. This is one way that we can get some input from a user. So to use it, it needs this import line up at the top. So if we don't have this import line up at the top here, if I go delete that one, it's going to highlight it in red, and I'm going to get this message, cannot find symbol. That's just Java's fancy way of saying it doesn't know what that variable is. And this one's not even a variable. This is the type scanner here. It doesn't know what a scanner is because we haven't told Java, hey, I want to use it out of the library. So sometimes this little light bulb will pop up, and sometimes it's helpful. Most of these suggestions are not good, and they're going to lead us down a bad path. But the add import is super handy. So Netbeans is pretty decent at saying, oh, do you want to import something from the Java library? So you can type it in by hand, or you can just let it suggest it and add it for you, and you're good to go. Now I can use this keyboard. So again, the book calls it SC. I think SC is a terrible variable name for it. So I like calling it keyboard. We can use it to get input from whoever's running our program. And to do that, we use next line. So next line gets me everything that they type in. And then we'll store it or assign it wherever we want to put it. So next line is always going to work with string values here. So if you want something that's a numeric value, you have to parse it or convert it here. So to get a number, we used integer.parseInt in a set of parentheses. And what we gave in the parentheses was the keyboard.nextLine. So we said, get their line of input, hand it to the integer to convert it, and store it. Yeah, we'll talk about the lab. Yep. So we got two inputs here. Then we added them together. Now we had to add the parentheses here to force order of operations because things operate from left to right. So we had originally a string plus an integer, and Java says, oh, a string plus an int, you must want to concatenate those things together because that's not arithmetic. And then plus another number, it says, oh, a string plus an integer, you must want to concatenate. All right, so if it doesn't automatically suggest the import, you can go type it in yourself as well. You just come up to the top and type the line in. It should suggest it. So if you don't have the capital S for scanner, it won't recognize it. And Java is very case sensitive. And there might be other errors around. So if you miss certain things, Java gets really upset with you. And it'll highlight here. They don't give you the best error messages, though. This says illegal start of expression. That's not really super helpful. But what it is you're missing the closing parenthesis. On this one here, this one says, hey, a semicolon's expected. So that's a pretty helpful message this time. And you didn't end your line with a semicolon. So dealing with those errors can be a little bit obnoxious for sure, because you get all sorts of weird things here. And so I'm missing a parenthesis, a starting parenthesis, but it says a semicolon's expected. And it also can't find symbol parseInt. So not not super helpful sometimes with some of those errors. So you have to look at the entire line and see what might be missing here. And that takes a little bit of practice for sure. It'll be a little while. And then if you wanted a numeric input with decimal places, it's double.parseDouble. All right, so let's take a look at the lab real quick. We'll talk about that some more. All right, so we're going to ask them for their name and then use it in the prompts below. So we did that sort of thing. Here, we said, hey, what's your name? Right? We get their name out, and then we're going to use it in the following prompts. So when you prompt, you can print something out and say, hey, please enter a number. They'll say, hey, your name, plus enter a number, please enter a number to add. So we're going to use their name in those prompts. You can follow along with that. That makes it seem a little nicer here when you deal with the computer. We're going to ask them how many hours they worked this week. Allow them to enter partial hours. So that means it might be a double, right? 2.5 hours or 27.325. I don't know. I'm sure you can come up with something, but I think generally we track stuff to the quarter of an hour. So ask them how many hours they worked and ask them how much they get paid per hour. So two different inputs, right? So we said, hey, enter a number, enter another number. Or, if we're dealing with doubles, right, the number of the decimal place, you have to have two different variables, two different places to store that information. And then we'll calculate their gross pay and display it. Then we'll also calculate an estimated net pay by taking 10% out for taxes and displaying the estimated net pay. So we'll say, hey, your gross pay should be this amount. This is what total you earned. Oh, and by the way, if you take out 10% for taxes, here's your net pay. Right, so that's a little bit of arithmetic, right? To take 10% out, right? A couple options. Generally, multiplying by 0.9 is probably going to be your easiest, right? Taking 90%, that's the remaining amount. It's probably easiest. But any way you want to do that math is fine. Okay? So we dealt with some doubles. So I was just going to keep going further in here to keep all the chapter 2 examples the same, or in the same location here. Yeah, definitely does not know what 90% is. 90% is not a numeric value. Nope. So 90% is actually 0.9. Right? That's 90%. All right, so far, all of these examples, the only thing we can really accomplish is every step that we've asked the program to do, top to bottom. There's no chance to make different things happen based on the input. So if I were to say, like, guess a number, I can't really do anything with it. Right? They could guess a number, but how am I going to check if it was too high or if it was too low or this sort of thing? So the next step we're going to look at is how we can make our Java programs make choices like that. We call them decision trees, that either this thing will happen or this thing will happen here. Right? So that you can, based on what the user enters, do different things, which is really fun. So we need to look at ways to relate variables. Right? These are relational operators. So a number can be greater than another number. It can be less than another number. It can be equal to a number. Right? So when you're dealing with numeric values, it's pretty straightforward. You can be greater than or equal to. You can be equals to. You can be not equals to. You can be less than. You can be not or less than or equal to. So we got a couple of different ways to look at those, right? So you have greater than or equal to. You have now to check if something equals, it's actually two equal signs together, which is kind of funny, but you think about it. The single equal sign is an assignment operator. So to say if a number equals another number, we need two equal signs. Then you have the less than and equal to, and then you just have the less than. Now, to say if it does not equal, it's exclamation mark equal sign. This exclamation mark is the not operator, so not equals. And it's weird that it's not double equals here, but apparently they didn't want to type so much, so it's just not equals. So not assignment, I don't know. This one always gets me. It's kind of funny here. But we can check if values are different. And I keep saying if. and that's generally how we talk about things in English, and turns out if is the keyword in Java as well. So I can say, hey, if, and then what an if needs is something inside the parentheses that is true or false. So you need a Boolean expression or a Boolean value inside the parentheses. Now that sounds really funny, but what that's saying, a Boolean is something that is true or false. It's yes or no. It's on or off. Right? So to say if something, you need to give it an expression or just a value itself that already is true or false. Right? So we can say, hey, if the first number is greater than the second number. Right? This will either be true or it will be false. There are no in-betweens here. Right? It's just one or the other. So that's what happens inside an if block, or an if parentheses, this if expression here. And sorry, it's super dry here. Oh man. So then what we're going to do to make code happen, if this is true, we're going to give it a set of curly braces. So I'm going to start a curly brace and hit enter, and it will add the closing one for me. You're welcome to type them both in if you want, but you'll notice if I click on the curly brace, Netbeans is kind of highlighting the other one here. So if I click on the starting one, it highlights the ending one. If I click on the ending one, it highlights the starting one. If I come down here at line 79, this is the closing curly brace, and it kind of pops up a little preview. Oh, hey, up here at line 7 is the starting curly brace. Remember, everything we've done has been inside the set of curly braces here in main. So now what gets to happen is code inside this set of curly braces. We say it belongs to, is scoped, will run if this is true. So in here then I can do something and say like your first number is bigger than the second. That, that's not very interesting, and they probably know that. But if this is true, anything inside of here will run. And we can add more code blocks here. More code, that sort of thing. Right? Anything you want to have happen inside of here, you can have happen if this value is true. Now, what do you do if it's not true? Well, so because we said it's either true or it's not true. It's one or the other. It's true or false. So this will run if it's true. If we want something to happen if it's false, we use the else keyword and a set of parentheses, or curly braces. So the else is the if not true option. Right? So either the if block will run here, right? This curly brace makes a block of code. The if block runs, or the else block runs, because it's either true or it's not true. Right? So if true, this happens. If it's false, the else happens. Your second number is bigger than the first. Sure. And not the most interesting stuff here. And you can have more lines of code, right? You can put as much code as you want to inside of these blocks. Okay? Let's give it a run. See if we can put in some numbers here. See what we get. And we're going to watch it happen. Right? We can we'll get this output or we'll get this output. All right, hi there, I'm Eric. Here's your number. I want 10 and 20, and a number at the decimal place. And our second number is bigger than the first. Right? 20 was our second number. 10 was our first number. So we got the else. We got the this was not true option, right? We got the else. So ifs are super cool because now our code can actually make some choices, make some decisions. We'll get more into this later. Don't worry too much about it right now. We're just going to start some basics here. The other thing we can do is, so this is all numeric values, right? And numerics are great, but if you want to check whether or not someone entered a particular value here, right? Like, hey, do you want to, I don't know, what do we ask? Do you want to make a shopping list? And they can say yes or no. We'd have to say, did they enter the value yes? And then we can go ask them for their shopping list, that sort of thing. Right, so what we're going to do, we're going to prompt them, hey, do you want to make a shopping list? And then when you're prompting people, I always encourage you to like tell them what you expect to get back out, because users will do the funniest things if you don't tell them otherwise. Yep, that's what we're going to use, red. So I'm going to say, hey, you should probably give me a Y or an N, because otherwise I'm going to be confused here. So we're going to let the users know what they should enter. And then we'll get their input or their choice. I'm going to make a string value here. We'll call it their choice, I guess, is going to be my keyboard.nextLine. Let's get the thing they typed in. Okay? So now I can't really say is a string greater than another string or less than another string. And it turns out we have a problem because that equal sign, the double equals operator, doesn't work for strings, which is a really big bummer here. So we have to say if choice dot equals, and now there's two options for equals. There's equals and there's equals ignore case. I'm going to say almost all the time we're going to use equals ignore case. It compares one string to another string, ignoring case. This little pop-up type of head here is kind of helpful here. It's fun. So we're going to say equals ignore case, and we want to check, does it equal a Y? So the string they entered, dot equals ignore case, another set of parentheses. What string are we comparing it with? So right now, my entire string is just the letter Y, but again, it's double quotes because it's a string, not the single quote or the apostrophes for a character, because we're comparing the entire string. And then I get an if block, my set of curly braces. So if they enter a Y, great. Now we can ask them, please enter an item for the list. And then we can say, I don't know, like item 1 or first item. Sure. Let's do item 1. Why not? Equals keyboard.nextLine. .nextLine. Okay, and then, I don't know, we'll ask them for one more item, so I'll copy that, do it again. A second item for the list, and we'll get 2 items. Now in this case, there's nothing to do if they don't want to make a shopping list. So that else block, it's optional. It's not, you don't have to have one. So SB Java, I don't post any code on D2L. All of it goes to the course repository, my GitHub repository that's linked out there. Because trying to deal with downloading code and all sorts of things like that is just kind of messy here. So you can find all of it. I don't think I made any changes there. In the content section, there's a link for it here, because you probably don't remember how to spell my name, and that's okay. We'll take you out to github.com/ericchinesky/CIS1500-winter2022-MW for Monday, Wednesday. And all the code's going to be out here as soon as I remember to commit and push. Yep, so you can always go back and review any of this stuff, for sure. Yep, so we don't need this else block. Right? If it doesn't make sense in your code to have something else happen otherwise, you don't have to include it. So just if you want to make a shopping list, great. We'll ask 2 items for the shopping list. Otherwise, nothing else happens. So when you're comparing strings, you can't use this equals sign. That's a big bummer. So you need to use this equals, and generally it's always ignoring case, at least when we're dealing with user input. And because who knows, some users love caps lock. I don't know why people like to yell on the internet, but some people like to use caps lock. Excuse me. Okay, so we can say if this, if that, sure. That should be pretty good. Okay, so now let's take a look at using more than one check here. So I'm going to say, hey, please enter your grade. We'll say like 0 to 100 here, and then we'll get an integer value for the, how about maybe a score? How about that? We'll say score. Then we'll call it grade. Why not? So if I want numeric input, I can't just say keyboard.nextLine. Next line, because it's going to yell at me, and the error here is incompatible types. String cannot be converted to int. This keyboard nextLine is a string. It's not an int, so I can't save it here. So remember, I have to take that step of saying, hey, I want to parse it or convert it here with integer.parseInt, given the string input, whatever they've typed in here. Now I've got their grade. So now what I'm going to do is I'm going to make a bunch of different statements here to figure out what grade we should get here. So I'm going to say if grade is greater than or equal to 94, you get an A. Or you got, right? I don't know. You got an A. Okay? If it was not greater than or equal to 94, well, now I want an else, but I want to do more checks. So what we can do is we can attach another if right away. So I can say else if grade was greater than or equal to 90. And you got an A minus. So with an if, else if, it does another comparison here. Because we get to do another qualifier and say, hey, if this one is true, let's do this. And you can have as many of these else ifs you want here. So if it's greater than or equal to 87, we'll say you got a B+. So we're going to work our way down here. This is called a chain of if, else if, else if, else if, else ifs. And the cool thing here, this is a chain of if checks. They are mutually exclusive. So what that means is one and only one of these will run. So as soon as one of these if blocks is true, this one runs, the else isn't going to even check. Because technically the if is part of the else here. It's kind of this funny thing. So as soon as one if is true, none of these other ones happen. Right? So one and only one will run. Because if something's true, the else doesn't even get looked at. So up above here, right, like if our first number was greater than the second, the else doesn't even get looked at. It gets skipped. So we can make this chain of them here. Else if the grade is greater than or equal to 84, right? And I'm just going to copy paste. Let's grab that. So if it's greater than 84, you get a B. If it's greater than or equal to 80, you get a B minus. That was a weird copy paste. B minus. And then we have a C plus, we have a C, we have a C minus, we have a D plus, we have a D. Right, so then we get C plus, and we get a C, we get a C minus. Oh, I forgot B minus here. Oops. B minus, C plus, C, C minus, D plus, a D. So we got to make sure all those numbers are right. So greater than or equal to 80 is a B plus, greater than or equal to 77 is a C plus, greater than or equal to 74 is a C, greater than or equal to 70 is a C minus, greater than or equal to 67 is a D plus, 64 was a D. And then what I'm going to do is, again, else's are optional here, but I'm going to have an ending else here. It's a default. No, it doesn't match anything above. So if it doesn't match anything above, then got an F at that point. You got a D, a C, a B, and A. I don't know. Those are probably right. But why is F? It's not even like a vowel. I don't know. A versus ands are hard. English is hard. So what we have happening here is we'll never look at this if grade is greater than or equal to 70 if one of these things above was true. Right? Because as soon as it finds an if that's true, that's the block that runs, and we're done. Nothing else is gonna run or get checked. Let me give that a little format here. Okay, so this way my check here is really nice. I just say, hey, if it's this one thing, I know it's not any of these above, because we're never going to get to this check if anything above was true. And then the else case, so if it doesn't match, right, if nothing else fits here, we're just going to stick with the F. So this is a chain of if, else ifs here, and they're mutually exclusive because one and only one of these will run. You're only going to get one grade assigned. Now this one, I need to have these else's here. Because if I just had an if block, it's not going to work, right? Because if I only checked for ifs, a grade of an A is also greater than or equal to 80. But I don't want to tell you get all these other letters. So we only want them to run if the one above didn't. That makes a big chain of them and lumps them all together, which is fun. Okay, we can do a chain of them. Let's see, I want to make sure I'm not going too far. Let me just grab this over here. Don't want to go too far. Trying to follow along here with chapter 2. Chapter 2 is a lot of fun. it throws a lot at you for your first chapter. We did arithmetic. Yeah, so dealing with special characters in our outputs. I don't think we did any of that yet. So in our outputs here, if I wanted to actually have a quote here, right? So your let's say favorite number is, I think we've got a favorite number up here, right? Yeah, we got a favorite number. We did some arithmetic with it, so it's probably wrong. But if I wanted to put it in quotes, right? I can't put quote signs in my string, because as soon as I try and put a quote in, it stops working. So what you can do is you can use these special escape sequences. So if you're going to give a particular character to Java, you can put a backslash first and say, hey, the next thing after here is special. So backslash quote is a special quote, not a quote mark that ends our string here. So it looks really funny, but I can now put quotes in my output here with this escape sequence. So this is an escape sequence. That's for the quote mark, to get a quote to show up in a string here. Let's see, so name, Eric, 10 and 20, some decimals. You don't want to make a shopping list, enter a grade. Let's do 94 as an A, and now we get our output here with a quote. All fancy. So quotes aren't the most interesting thing to add here. But other things we can use this escape sequence for is you can have, if you want tab, that's backslash T, right? You can add your own line breaks with a backslash N. Now to get a backslash N to show up here, to get a backslash character, I need to put in backslash backslash to say, hey, I really want this to be a backslash. So backslash meaning it's an escape sequence, it's a special character here, and then all that actual character is here. And then if I want to put that in quotes, it's backslash quote, backslash quote. This just looks awful. But all of this to get a backslash N to print out here. The line break. So a line break will make it go down to the next line, right? A tab will tab stuff in, Eric 10 and 20 and 7.7 and no shopping list, and let's do 93 this time. Now we got an A minus favorite number. If you want a tab, so you don't really actually see that, but if I'm highlighting, this here is one whole tab. I gotta put that in the backslash T. You add your own line breaks to the backslash N. It will go down itself. Right, so I did the backslash N, oops, wrong, go to this tab, and then I went down a line. So backslash T, backslash T, and if I want to put that in quotes again, right, backslash quotes. I'm going to actually put this ahead here. So we'll put it at the beginning. Tabs are fun for like doing some formatting stuff, because it'll bump everything in and kind of align it for you nicely. 10 and 20 and 7.7 and no shopping lists, and let's do 90 this time. Right, so tab will do one whole tab for me here. It's kind of hard to highlight, but it's there as one tab. Backslash T, backslash N as a line break. Those are some common ones you might see, you might work with. Right, we did scanner. Yep, we did doubles. Those ones are good. We did print. So if, depending on what you want to do, right, and how you want your output to look, we've always used these print lns, and print ln will add a line break for us at the end. So it prints your line and then adds the line break so the next thing happens down a line. There is an option to just print and it won't go down a line. I don't use them very often. I think those are a little bit more confusing, but you can do that if you want. Oh, and the book will also show you, for an if block, if you only have a single line of code, you can technically skip the curly braces. I think that's a terrible practice. And actually, years and years and years ago, because I remember it, but you folks are probably still in like early school. There was a bug with the Safari browser in macOS, and it was actually bad enough that you were able to break the SSL security on the browser. And the entire thing happened because one of the developers there didn't use curly braces after an if statement, and bad stuff was happening. So it's ugly. So I'm just going to always say use the curly braces. Okay, it's just much better. We're just always going to use curly braces. Long story, but always curly braces is better, much better. Okay, so far we did our ifs, we did our if-elses, we did those chains. Now we're going to look at one last thing to wrap out the chapter here, which is fun. So the last thing we're going to look at is how we get code to repeat. So not just running one time with an if or an else, but running all the time here. So let's do a little guessing game here. So let's say we'll have an int for the magic number is equal to, say, 42. And then we'll ask them, guess a number 1 to 100. And then we'll get their guess. So their guess will be integer.parseInt, given the keyboard.next line. Right, whatever they type in, let's turn that into an integer value here, and let's check. So if I want this to happen over and over and over, well, let's do it one time. So we can say, hey, if my magic number, how about the guess? If the guess does not equal the magic number, then we want to do something. If it does, right, if it does match here, then we'll say you guessed it. But if it doesn't equal, right, I want to tell them too high or too low. So inside this set of curly braces for this if block, I'm going to check again. Now, if the guess is greater than the magic number, we'll tell them too high. If it's not greater than, it must be lower, so we'll tell them too low. Then I can have them guess again, right? Guess again. Now, and guessing again here is a little bit tricky here. That's not going to work very well. But this is just a simple check here, right? Now, this is going to look silly with this if, else if, but this is going to make this easier for us here to repeat. Because we could have just said, hey, if it does equal, you guessed it, else if it's greater than, too high, else if it's too low. But what we want to do here, so instead of an if here, we can use a while loop. So a while loop runs the block, then checks if the value is true, and runs again. That's a little long. Let's bump that down. Let's do a couple lines. So if this is true, the block of code will run. Now, you can't actually have else's after a while, which is a bummer, but that's okay. So technically, this won't run until this is not true. Right? Because what a while is going to do, it's going to say, hey, if this is true, run everything inside of my set of curly braces. If it's not true, it doesn't run, and then it finally goes on. Once the while condition is not true, the code continues. Continues below. So we can't get to below the while loop until this is false. So if it's true, we're stuck in here. So what we need to do then is we need to ask them again. So we'll say guess again. Guess again. And then I don't need to say guess is an integer. I just need to give guess a new value. So I'm going to assign guess a new value of whatever they typed in here. And we're going to tell them too high, too low, or guess again. Now the other thing we can do, which is kind of fun, is we can have a number of guesses. Number of guesses. We're going to start off at 1, guessed it, and we'll say in number of guesses, guesses. We'll count how many guesses it took for them. So every time that we're going to guess again, we're going to take our number of guesses. And remember, we've got some of these shortcuts here. I could say plus equals 1, because I want to add 1 to number of guesses. Or we even have some more shortcuts we can use. Do we get to those? I thought we got to those. I just want to add 1. Let me double check. You might not have gotten to that yet. Let's see. Trying to find it in the arithmetic. No, we didn't get to it yet, so that's okay. So we'll just do plus equals 1. That's easy. So hey, let's add 1 here. Yep, I think that ought to do it here. Okay, so number of guesses plus equals 1 will add 1 to the number of guesses. So every time they have to guess, we'll count. So let's give it a try. So you throw out some numbers here. We're going to guess that magic number. Oh, 10, yeah, 10 and 20, sure. 7, no shopping list, 90 for a grade. All right, let's guess a number. 1 to 100. What do you think? $88. All right, so 88 is too high. Guess again. We probably don't need another exclamation mark there, but that's okay. So 88 was too high. Let's guess again. $22. 22 is too low. Guess again. $42. We guessed it in 3 guesses. Look at that. Hooray. Yeah, I plugged my watch in to charge it. Thanks. Cool. So what a while loop lets us do is the code will run, and then we're going to check, is this true or false? If it's true, run again. If it's true, run again. So what you have to be careful of is you want to make sure that you are changing the value of what you are checking. So it's kind of long, but if my guess never changes, my while loop will be stuck forever. I'll just be in an infinite loop. So you have to be careful to not get stuck in a loop. You need to make sure that it can eventually change so that it will stop running. Right? It's not helpful if we can't ever guess again. But it's real common, as we're running our program stuff, that'll happen sometimes. So while loops are real cool like that. They're pretty cool. All right, so we need to talk about the lab for today and then the first project. Do you want to take a break first, or do you want to just power through, do everything, and then take a break after? Up to you folks. So that wraps up Chapter 2. We've looked at all sorts of fun stuff here. What do you think? Yeah, we can do a break first. You got it. All right, why don't we take 10 minutes? We'll come back, and then we'll talk about the next lab and the project, for sure. All right, you got it. Let me put some music back on, and we'll take 10, okay? Let's go here. Break time, so we'll come back and say 11. All right, we'll be back in a minute. Howdy, folks. Welcome on back. Alrighty. So we got a couple things. We're going to talk about our next lab assignment here, and then we'll talk about the first project. Okay. So what we're going to do for lab here to kind of practice some of this here. So I'm going to give you what's called pseudocode. Now, pseudocode means it's like code, but it's not code. So it's like the English version of things. I was checking my watch charge, and apparently that's not a good connection. So the goal here. Oh, I didn't. Let me double check what time those are. It's a good question. Not that tab. I want this one here. I got to do a tab that's not on the screen that I'm sharing, because that's no good to share my email with everybody, right? Let me check. All right, so we'll go. Yeah. Looks like, let's see. I was thinking, so he's going to do 2 different sessions throughout the week. So one will be before the Tuesday class, so we'll do 5 to 6 on Tuesdays. And then another will be after our Wednesday session, 12 to 1 on Wednesdays. And hopefully 1 or 2 of those might work for either of the classes, because he's doing the tutoring sessions for both my Monday, Wednesday, and the Tuesday night. So I think doing an evening and then a afternoon hopefully will fit with your schedule one way or the other. So that was Tuesday 5 to 6 and Wednesday 12 to 1, right? So it should be after, yep, right after class or right before class, either one of those. But they'll be virtual, so just, you can hop on a Zoom session. So I'll get all the details from him. I think he was going to post the links in D2L for us. I'll check with him. Yeah, I can email him here in a second. So, all right. So for our lab, we're going to build a little program. Yeah, no. So they're both CIS 1500. Yep. Yeah, both CIS 1500. Yep, I just have one that runs Tuesday night. So we only meet once a week for that class, and we have our class that meets twice a week. So as you can imagine how fun this is, 2 hours at a time. Imagine doing a 4-hour straight for a programming course. All right, so for the lab, we want to build a rock, paper, scissors game. So we're going to ask the user if they want to play a game, or play rock, paper, scissors. Rock, paper, scissors. Scissors. And we'll say while they want to play. If their input was a Y or something. We're going to ask them which they want to throw. Rock, paper, or scissors. We'll say the computer will always be rock. So if the player won, right? So what beats rock? Paper beats rock. Player is paper. Right? If the so I guess we're just checking here, right? So tell them win, lose, or draw. Right, to do that, right, player wins if they are paper. Player loses if they are scissors. And a draw if player is rock. And then we're going to ask if they want to play again. So this idea with this loop, you want something inside the loop to change. So our loop then will be, as long as their input was Y, we'll tell them whether or not they win, lose, or draw, and then we'll say, hey, do you want to play again? And then we'll change whatever we're checking here in the Y loop. So as long as they want to keep playing, yes, I want to play again, yes, I want to play again, yes, I want to play again, they can keep playing rock, paper, scissors until they get bored of it. So we're going to use a basic loop here, similar to this, a little bit different, right? And anytime we're dealing with string input, it has to be the equals, ignoring case, or equals operator. So like, hey, if you wanted to do this, yes, we'll go do that sort of thing. So instead of an if here, it's just a while block. And we'll just keep on running over and over and over again. So really, these are inside the whiles. Excuse me. So ask if they want to be rock, paper, scissors. Computer's always rock. And then you tell them if they won, lost, or draw. And then ask if they want to play again. So I think that's tabbed in a little bit more. Yep. Does this part make sense? So it's not really code, but it's kind of laid out a little bit like code. But here's breaking a problem down step by step by step by step. This is the hard part of programming. That's the real art of it. There is science to computer science and programming as well, but the problem solving, the creative bit, the how do I take a big complex problem and break it down into small pieces that are easy enough for a computer to do is really cool. And that's kind of this idea. So we'll do this often, just kind of sketch out what we think the flow of code might be here. This is called pseudocode, or like it's a model that you can then go validate and, okay, let's see. So if I were to enter something, let's see what happens, right? That sort of thing. And you can just kind of walk through it in your head. Okay, so that's what we're going to do for the lab. So let me post that here. Let me grab our links. I'm going to put a new lab assignment out here. Yep. 1500. There we go. Yep, so ideally we can get this one done before 11:50 or so. And if you're having any issues, let me know. We can screen share. No, this is lab 3. The project, I'm not going to give you any pseudocode. This will be due next week by 10 a.m. 10 points for labs, I think is what we were doing. That sounds right. Nope, not a file. A lab, there we go. And this goes, oh, that's right. I can make categories for assignments here, I found out. Text submission. All right, and then we need lab 3. Yes, 1500, winter 2022, lab 3. On our Java template. Excuse me. And feedback pull requests. Okay, so we copy that. Please submit the feedback pull request URL. Oh, and let me commit this code here so I can reference this actually as well. Our GitHub client. Okay, so it should see a bunch of stuff was changed in our chapter2.java file. So write a program that lets the user play rock, paper, scissors. They want to play, and while the answer is yes, ask them what they want to throw, tell them win, lose, draw, and then ask if they want to play again. Play again. See the pseudocode code here. UDO. There we go. All right, here's the GitHub client. This is 1500. Crow. Most of my classes are. Yep. So we were given the choice as faculty at Oakland Community College whether or not we were going to have classes remote or in person. I wasn't given the choice for my class over at Dearborn. But I'm still running that one in the flex format, so I've had like 3 people show up, which I feel pretty good about, being in a room with 3 people in a pretty large room. So not too concerned, but our rooms are not the largest, and I'm sure they're not ventilated super well since our building's really old at OCC. Come on, GitHub client. Work with me here. There we go. 1500, Monday, Wednesday. I don't know. Sometimes I feed the trolls. Sometimes I don't, official Gatman. All right, so here's rest of chapter 2. So when you do this, it's not going to be in the light blue. You mean like yeah, because these are comments. This is what I left here. So this is all comments. This is not Java code. This is just comments I left here. The Nightbot. Yeah, I've got I think it's Nightbot does a couple commands. I think it's !help. We'll link you out to the different commands I have. Nope, it doesn't. Do I have Nightbot? class. Oh, I do have Nightbot. Oh, I don't remember. Command. Maybe it's command. Commands. There we are. One of these days I'll remember the right one here. Anyway, so let me refresh this here. We'll go to chapter 2. I want to give you that link right inside of the assignment here as well. Oh, I committed, but I didn't finish pushing. Maybe now it'll finish pushing. Maybe. Oh, I saved. There it goes. There's the comment. Pseudocode for lab. So I don't think I actually saved the file. I thought I hit save, but every time you run your program, it automatically saves it for you. But you'll notice like now these things lit up as green when I added lines. And now I should have the comments here. There we go. I'm going to link this out here. You can like click a block of line numbers, which is fun. We'll say, see the pseudocode. My copy pasting into D12 doesn't want to work very well. All right, so that's lab 3. Okay, and let me go edit these real quick. I can put them into the lab category for you. That in the lab category. I'll make life a little nicer. And labs. All right, cool. So we got those, and now we'll talk about the project. So we're going to look at project 1. So again, I've been told, and it is intentional, that sometimes the labs are a little bit vague. And the idea is I want you to go through that problem-solving process, that creative process of, what are we doing here to solve this? So doing 2 weeks from today, that'll be the 7th. Wow, looking at February already. So 10 a.m. on the 7th, and I'll go over the solution that day in class. So I think that we can do about 10 points here. I think, no, maybe it was 8. I'll look and see. Project 1. One in, oh, do we have existing? Nope, I have 0. Okay, so we'll do it. Here's project 1. Projects. Okay. So we need another link here. I've got this link already, actually, which is nice. Let's do project 1. Copy that link. I'm going to submit the feedback pull request URL in addition to, or also, and it looks funny having those be upper and lower there. So URL and a self-assessment using the rubric. So for projects, I'm going to give you a rubric, and it'll say, hey, if you accomplish this task, you get these points. If you accomplish this task, you get these points. And we'll go through that in a minute here. So I'd like you to assess yourself using the rubric here. So tell me, hey, for this item, I got these points. For this item, I got these points. For this item, I got these points. Because I'll give partial points, right? If you only get 2 of the 4 tasks accomplished, fine. You can have the points for the 2 that you got accomplished. No problem there. If you got like half of the task accomplished, give yourself some partial points. Say, I got some of it, but it doesn't fully work all the way. That's fine. It's no big deal here. Okay? So any way that you can get that part done, well, I'm good with. All right, so we're going to write a Java application that helps a user build a shopping list for their party. Okay, that's the idea. So we're going to have this little party, and we need to know, well, how much do we need, right? Was it 10? It was 10 points. I'm sorry, it was 10. Let's change that to 10. Okay, so the first thing is we're going to ask the user for their name and use their name in the rest of the prompts, right? Just recycled from the lab, right? It's nice when programs use your name. Sure, we'll practice that. Okay, so we're going to use their name and talk to them by name. Then we're going to ask them how many people are coming to the party. Right, so we need to know, okay, how many people are coming here so we can figure out what we need to go buy for our recipes here. Okay, and then ask what they are serving. And now we're only going to give them a couple choices here because this is kind of difficult to make these things for a party. So we can serve hot dogs. We can serve, what else do we want to serve? How about some mini quiche? Or we can serve, I don't know, I'm hungry right now. How about some kind of dessert, maybe? Dumplings. Okay, dumplings. I like it. Dumplings. Okay. Now for hot dogs, we need 1 pack of hot dogs for every 4 people, and 1 pack of buns for every, I think they now come in 8 and 8s, right? You get a pack of 8 hot dogs and a pack of 8 buns, right? Because they match, right? For mini quiche, you need 1 pack for every 6 people. And then we need some sauces here. So, and then we're going to add, and one, oh, what's the dip? It's like a, I will just say pack of dip for every 10 people. Okay, and then for dumplings, you need 1 bag of dumplings for every 8 people. And now we need 2 different kinds of dip because some people like to dip theirs in a spicy sauce, and 1 spicy dip for every 12 people, and 1 regular dip for every 12 people. Okay. So we're going to have to do the arithmetic and say, okay, based on how many people are coming, how many of these things do we need to buy? Right? We're going to output the number of items of each that need to be purchased. Okay. Now the tricky part here, right, is that you can't buy half a pack of anything. Right? You can't go to the store and say, hey, I need, 0.25 packs of hot dogs. So everything needs to be rounded up. To be rounded up. So we got a couple ways of doing that. Okay, 2 different options. So we'll talk about those. So the first one here is the easy one. So if you have a number, and we want to, let's ask them to enter a number, the decimal place, and we have double sum decimal equals a double dot parse double given the keyboard dot next line. Next line. So to round it up, which is, I don't know, we'll just say your number rounded up is, now in Java there's a library called math. So math dot gives you all sorts of cool math functions. One of them here is poorly named ceil, which is short for ceiling. Now the definition of ceil is awkward here. It returns the smallest, closest to negative infinity, double value that is greater than or equal to the argument and is equal to a mathematical integer. It rounds up. So math.ceil, given some decimal, will round your value up, plus. That's probably the easy way to do that. Okay? So math.ceil, given some number, will round it up. Okay, we'll worry about some harder ways later. Okay? See math.ceil. Ceil. Does that make sense? Okay, so let's add a rubric here. So this is for project 1. So again, I'm just going to have the 2 scales here. It's not like an English paper. So it's either missing or it's complete. So if it's missing, there's no points. If it's complete, there's 2 points. Oh, sure, SB Java. Yeah, anything you want. Yeah, use anything you want in the book. So we ask them for their name and use the name in the prompts. So all the prompts will say, hey, so-and-so, hey, so-and-so, hey, so-and-so, right? This is ask what type of food, hot dogs, mini quiche, or dumplings. Now, if they don't enter one of those types, tell them you can't help them and to try again. So, right, to check strings, right, we need to check, hey, does it equal, ignoring case, does it match this? And if it doesn't match any of them, like this kind of trailing else case, a default case here, we'll tell them, hey, we can't do that for you, go away. We can't help you. Okay? And then we're going to have 4 points here for correctly makes the number of items. I guess so this will ask for the number of guests. And then the last one here is correctly calculates the items required rounded up. Okay, and then again, this overall score thing is nonsense. I wish I could get rid of it in a rubric, but it doesn't let me do that. So don't worry about this overall score thing. This is just overall score. Okay, so this is how you get your points, right? 2 points for doing this, ask them name, use it in the prompts. 2 points for asking the type of food, 2 points for if it's not one of the known ones, 2 points for the number of guests, and 2 points for the correct calculations. Okay, so you'll turn in the pull request and then tell me you got 2 points for each of these items. Or if you only got partial points, you got partial points. Okay, so that's the project. So we're not even going to use a while loop in this one here. We're going to get into that in later chapters. I want you to practice it for lab, but for the project here, get some input, do some arithmetic, those sorts of things, practice some of those Java basics. And we've got some time. So hopefully this one is relatively straightforward. I'm happy to answer questions about it here. But again, I'm not going to give you like that pseudocode that's like, hey, do this step, do this step, do this step, sort of thing. And we'll go from there. So that's the first project. Any questions? You folks are doing great. Okay, and then the last rounding example. You commit that. So it's nice, you don't have to import math. You just get math, which is really cool. I think it's java.math. So anything in this lang library, this is like the base language, automatically comes with it. Oh yeah, the quiz. I'll post the quiz. Thank you. Yep, let me post that. So we'll do a quiz on chapter 2. We got a week for that one. We got that one. All my dates I imported and just hit everything because they're repeats from last semester. Same quizzes. They're just the test bank ones from the chapter. I used to feel bad about it, but I think now it's just easier because it lines up great with the book. So next week, the 31st at 11:59 p.m. is when the chapter 2 quiz is going to be due. Thanks for reminding me. And get your scores automatically. Only one attempt on these ones here. After that chapter 1, I felt fine to give everyone another try. So right away you can see nothing, and then you can see the answers after the due date. Gotta add this timer too. So that is 31st. And then the answers will open up for you. And again, let me know if it marked anything wrong on you. Sometimes those fill in the blanks are a little bit tricky with just looking for particular letters. So it's not the smartest tool. Okay, so that it should all now be in here. So we got our lab 3 due, we got the project due. So this calendar should stay up to date because all the deadlines are in D2L, which is pretty cool. And I can actually add those SI sessions too. I just need the Zoom link. So I'll ask Mr. Tim about that, and I can add those sessions in here for you as well. So I don't know. Some people like calendars, some people don't. I love calendars. I have one master Google Calendar for anything and everything in my life. So my kids' events, my wife's stuff, all of our family stuff goes in there. All the work stuff goes in there. It's really nice to have it all in one little calendar view. Okay. right, so we got the rest of today. We can work on that lab. We got all week for that one. If you got questions about the lab as well, happy to talk about it on Wednesday. If you got questions about the project, again, general questions, please ask any way you want. I prefer questions in that public Discord channel, just because if you're not sure about something, someone else probably isn't sure about it either. So your general questions are fantastic for that. But if you want to send them to me direct, that's fine too. Happy to answer them over email, call, text, direct messages, and we can go from there. Yeah, for sure. So we can, I'll end the stream here, and if you want to message me, I can kind of take turns putting people into screen share sessions, and we can go from there and help you out, either over Zoom or on Discord here, or any way you need, okay? All right, folks, I'll go ahead and end this, and then just message me if you want to chat until the end of class. I have a little bit of time between classes. I've got a class starting at 1, so I've got some office hours today. Yeah, shoot me a message, SPJava, either on Discord or if you want to hop on Zoom, and I can set it up for you. Yeah, we can look at that lab too. All right, I'm just going to go refill my coffee cup real quick, and then I can hop on screen shares with people. All right, folks, I'll be around answering questions. Take care.